Greetings fellow Earthlings and welcome to this tiny garage. If you're a regular viewer, then welcome back. As promised, we are back in the garage this week. If, on the other hand, you're feeling a little stressed out right now and you want me to hurry up and get to the point, then you probably stripped a thread just like I did. Now, I promise I feel your pain, and in addition to that, I video all of my mistakes, and I was emotionally prepared to get eviscerated in the comments section, but that didn't happen. Not a single bad comment. Instead, you kind folks sent me this, which is every way that you guys know to fix a thread. Thank you. And so this week, what I'm going to do is go through some of these and name some names, and then pick one of them to fix the thread that I stripped on this Porsche engine. Now that brings us back to something that a lot of you mentioned, is that if you work with aluminum or aluminium for long enough, it's not a question of if you're going to strip a thread, but when. And that brings us to the Mohs hardness scale again, which, if you remember, aluminum is the cottage cheese of metals. And so therefore we are not going to feel downtrodden, and we are not going to panic. We're going to do what the professionals do, which is take a deep breath and fix it. Last time we were in the tiny garage, I stripped one of the 6mm bolts that holds the secondary air pipe in place. And so one thing you might ask is, instead of fixing it, what about just buying a new engine half? Which is a little excessive maybe, but I thought for a giggle I would call up Porsche and say, hey, how much is it for a Bank 1 engine half? And so the first thing they told me is that you can't just buy one half, you have to buy the Bank 1 and Bank 2 engine halves. And just to be clear here, this is just for the outside casings, no cylinder heads, no pistons, nothing. Just the metal shell with the cylinders in it. And so they said that, yeah, it would be a special order with no returns. There's 3 of them left in Germany, 3 pairs of halves, and it would be $12,000. And so obviously that doesn't make any sense at all. And so looking at used then perhaps instead, in the used market, if you can find a matching pair, it would be about $2,000 or so to just get those engine halves. Plus all the expense involved and time of taking the engine completely apart again and then putting it back together around those engine halves. And of course there's no guarantee that you won't strip one of those bolts on the way in anyway. So that's why fixing it really is the only option that makes sense.
Hold on, what's the dog doing? Oh yeah, subscribe now. Delta says thank you.
The eagle eyes of subscribers Eddie Figueroa and Tom Thompson both noticed that in the hole where I stripped out the threads, there was still some threads remaining in the bottom. And their suggestion was that perhaps I could try a longer bolt of the same diameter and just try to catch more of those threads in the very bottom, which is a great idea. Now, subscriber Bernard McLake went further than that, and he said that in aluminum alloy, if your remaining threads in contact with the bolt are 1.5 times the diameter of the bolt, then you should be able to torque that bolt to spec. Now in this case we're dealing with 6mm bolts. That would mean we'd need 9mm of thread remaining. We don't, and so we do need another option. Now another thing that Bernard McLake mentioned, along with subscriber Mike Davies, thanks very much for all these suggestions everybody, is to try to start with a thread chaser. Now a thread chaser kind of looks like a tap, though a tap is hard and sharp and it's designed to cut new threads, whereas a thread chaser on the other hand is designed to clean up dirty or mangled threads. And so in this case we just don't really have any threads left to try that, but that would be one of the first things to go to. Now we are talking a lot about bolts and threads, so let's take a look at what all those numbers mean.
This bolt is an M6-1.0 times 35mm. So the M tells you that this is a metric thread designation, which makes sense on a European car. Therefore the 6 means the bolt is 6mm in diameter, which it does seem to be. Thread pitch is the distance from the top of one thread to the next. In this car, it's very obviously just 1mm, and that's what the 1.0 stands for. The final number is the length of the bolt, not including the head, in millimeters, in this case 35 millimeters. One thing that is not mentioned in this series of numbers is the head size, and in this case, and in the case of most of these engine bolts, it's 10 millimeters. Something else a lot of you folks mentioned is a tap and die set. This is a tap and die set, lent to me by my neighbour Jim. Thanks, Jim. Now, we can't use it because it's actually an imperial set in the dreaded inches. And you can see inside here, this gauge is in TPI, or threads per inch. So the bigger the number, the finer the thread. Then also this is a die. Imagine a die is a hole. You use it to cut a bolt. And then in the lower floor, we have the taps. And so a tap is a bolt that you use to cut a hole. There they are. There they are. The antithesis of each other. They complete each other. A little weirdly sexual there. All right, so then this thing is a wrench. If it's for the tap, then it's a tap wrench. If you're using it on the die from the upper floor, then that is a die wrench. We can use that. It's adjustable. Going to help us use our tools.
Hit the notification bell. It's up there.
Yes, please.
If you're stuck by the side of the road somewhere, retapping a stripped bolt hole may not be a realistic option. And so some of these liquid solutions might be a way to get you home. Now the first one, believe it or not, is superglue. You could put some superglue into that hole and onto the threads of the bolt, tighten it as much as you can, and hope for the best that might get you home. If you are going to go the superglue route, I'd recommend trying to get a name brand like Loctite. Not all superglues are super. Thank you to subscribers Paul and Joy Quilter for this suggestion. JB Weld is a two-part steel reinforced epoxy that displays steel-like qualities once it's set. And so in this context, what you would do is mix up that two-part epoxy, put it into the bolt hole, and then put automatic transmission fluid onto the threads of the bolt, and that's going to help act like a release agent and stop the JB Weld from actually gluing to the bolt. And that way, when you push the bolt in there and let everything set, when you come back and try to unscrew that bolt, if you're lucky, you should have new threads formed out of JB Weld. Now there are other products like that, including the Permatex liquid metal filler, and also from Loctite they have a thing called Forma thread, which is a very similar sort of situation. Now in my opinion, those solutions are kind of a temporary get you home sort of fix, but that could be perfect for what you're looking for right now.
As we really don't have enough threads to consider restoration, we are deep into thread replacement territory. And that is kind of scary because it means we do have to drill into this $12,000 engine case. So here's what I decided to do. When I was putting the sump plate on, two of those bolts felt funny. I know now that that feeling of being able to twist the head off a Play-Doh character means that those threads are probably on the way out. I felt I could maybe put it off until I drained the run-in oil, but I'm going to use those as a way to practice two different methods to replace those threads. The local auto parts store did happen to have this metric tap wrench set for $10, and it has the M6x1 tap that we need, just in case it's of any help. Handy to have around is what everyone said, so I got one. Subscribers Andy Hayden, Lester Polsford and Stuart Hartley were all about the Heli-Coils, so I got some, and we're going to try them first. Those are the little Heli-Coils themselves. The kit comes with 3. You can buy more very cheaply after. It has a tap and the magic handle. Subscribers Warren Lucifer, 2 Bugs and a Back, and Tim Durham were all about Time-Serts. Tim was saying that Time-Serts are what Porsche use themselves to fix stripped threads. So that's a good recommendation. The kit is more comprehensive than the Heli-Coil kit. Better quality tools for sure, and that is a Time-Sert. It is a solid piece of steel with threads on the inside and the outside. The Time-Sert kit also comes with this countersink bit that allows the Time-Sert's flange to sit flush with the metal surface. And finally, maybe a great idea, maybe a terrible idea, I got this $20 drill press from the Amazon, of course. And what I did also was from the Harbor Freight, they have these really cheap spirit levels that I'm calibrating on my floor. And then I hot glued them onto my new high quality drill press. I'm practicing on the sump plate bolts because they are relatively lower risk than the actual bolt for the secondary air pipe, though there is definitely a risk of getting metal shavings into the oil, and so I am covering up the oil sump as best I can, and then reusing the tasteful green on green box from my new drill press. So here is the tap from my new kit, and I'm just using that to sort of see what state those threads are in, and really there's very little gripping at the top, and you'll see here that is the first hole that I'm going to use the Heli-Coil on. And then this is the second hole that I'm going to use the Time-Sert on. And that one's a little better, but you see how deep that tap goes before it bites anything? Now this is a good hole, and it's nothing like that. So really there is nothing to restore with a tap or a chaser.
I would like if you would hit the like button.
So here we go. Helicoils, everybody. This area is very uneven, and you could maybe take the pipes off, start removing parts. What I decided to do instead was use these lead shot bags to give me a more stable, predictable surface to work on. And here is our OEM kit. It needs a 1/4 inch drill bit, which doesn't come with it. I happen to have one. And here we go. What I'm doing is measuring the depth of the holes overall with something that's much thinner than the diameter to make it go all the way to the bottom. Then I'm transferring that mark onto my drill so I don't go further than the hole is already. Marking that with a bit of tape. To begin with, I'm using WD-40, of course, as my drilling and tapping lube. Later on, I'm using motor oil. There are better things. Okay, here we go. I'm just trying to keep my spirit levels inside the lines, and that seemed to work okay. First thing doing there is vacuuming up all of those metal shavings. So there we go, step 1, a slightly larger hole ready for new threads. And that brings us to an option mentioned by George Pratt and Lester Polsford. They're saying, yeah, you could drill it out like that and then put all new threads for a slightly bigger bolt and then just use a bigger bolt. You'd also have to drill out the sump plate as well in this example, but that is a valid answer. It'd be a very similar situation to this. In this case, I am using the tap that came with the Helicoil kit. That is important. It is matched to work with these particular Helicoils in this particular hole. Subscriber Andy Hayden kindly shared the tapping technique they were taught in college. Apparently, you are supposed to turn a half turn in the cutting direction and then back a 1/4 turn and then keep going in that manner. I wouldn't have been a good student, but it did work in the end. I marked the depth that the tap achieved and then used the shop air to blow out any remaining wreckage from within the hole. Here is the magic installation handle for the Helicoil. It has a slot in the bottom that accepts the tang from the Helicoil and allows you to grab it and twist it into position. That collar by my thumb can be moved down to help when installing short Helicoils into shallow holes. Subscriber Arnold Mosk shared that it is a good idea to put blue thread locker on your Helicoil before you install it to stop it from twisting itself back out. In this instance, I didn't do that because I wanted the option of possibly taking it back out if I screwed it up. When the top of the Helicoil is a 1/4 to a half turn below the surface, you're good. Now the final step is you take that magic handle and you turn it 90 degrees so it is hovering perilously above that tang, and then you whack it mercilessly, in this case with my hand, and it snapped that tang off. Now the next thing is, how do you get that Helicoil tang out? I tried my regular magnet, not a sausage. I tried my fancy rare earth magnet, no joy. So plan C then was to tape it up just so I would know where it went. And I decided to spin the engine over upside down. Then opening that up with a license plate underneath it so I would hear it, I tickled it with a wire, and there it was. Time to try out these Time-Serts. This kit is very nice. It does cost twice as much as the $32 Heli-Coil kit, but all the tools are present, including a drill bit, and they're all very nice quality. First thing I noticed here is the drill bit is much better at cutting through the aluminum. Then, of course, cleaning up as much of those metal shavings as possible. They are my least favorite part of this whole thing. Now you can see that that hole has been drilled out. There's not really any threads remaining. We're now going to use the countersink bit to countersink a section for the flange to go in. The shop air really was the best way of cleaning that out, even though it pains me to put more metal shavings all over the shop. This is the tap that came with the Time-Sert kit. Works really the same way as the tap that we had for the Helicoil kit. And finally, we use this installation tool. We want to check the depth first of all and mark that on the tool. Then I did move over to using engine oil here as my lube. It's recommended to use that on the install tool as well. So here's the Time-Sert going onto the installation tool. And you just keep screwing that in. And eventually it's going to get more difficult that you kind of need the wrench to continue. I was concerned that the top of the flange wasn't going below the level of the engine case, but you do need the wrench to do that final little bit. Then you keep going until it starts feeling easy again, which was right there, or until you get to that line you drew on the installation tool. And that's it. So let's compare the results. That's an original bolt hole in good condition, and it feels pretty good. Here is the Time-Sert. Really feels pretty much the same as the good bolt hole. Slightly rougher, maybe just because it's so new. And then the Helicoil was a little weird to get it started, but once it was in there, it did feel good, and it kind of tightened up towards the bottom. That's the Helicoil. It really does look like those are actual threads, but that's that coil of wire. And here is the Time-Sert after installation, distinctive with that darker metal color, and of course that flange around the edge. All right, decision time. I think from my little experiment here, the Time-Sert is the one I want to go with. Another thing too is I'm not messing around with these metal shavings. I'm wrapping this thing up like E.T. That metallized duct tape is very handy here. All right, those are the threads that are ripped out at the very top. There's not enough there to work with. So step one is get rid of everything that's in there. That drill bit was much better than the Black & Decker drill bit, whatever magic is in that thing. Now we're lubing up again and doing the countersink tool. It has a flat edge on it, so you kind of know when you got to the end, it'll just stop going any deeper. Then we check the depth on the installation tool. Then we're tapping that hole with the tap that came with the Time-Sert kit. Now final bit of lube to install the Time-Sert itself. And then that last bit of turning till it gives in. Then I just kept going till it went to the line, which is in the instructions to do that. Then unwrapping our patient, and it's done. For any of you who are actually going to do this, those measurements might be helpful. And if you're wondering what happened to the thread that I stripped out, look at it. It's like its own little Helicoil stuck still on the bolt. Now, finally, we can get back to where we were 3 weeks ago and install this secondary air pipe and all its paraphernalia. And yes, I'm using a slightly more conservative 10 Newton meters this time around.
I wanted to send out a special mention to subscriber MC02Fly, who suggested Rivnuts. Now, in this particular case, I didn't want to use Rivnuts because they leave a little flange at the top, which wouldn't have worked in this case, but they do look awesome, and it makes me want to build like an aluminum robot or something, just to have an excuse to use Rivnuts. So check them out. And finally, thank you, subscriber Bernard McLake, for some insight into the big boy professional solution to this problem, which would be to fill the hole with material from a TIG welder and then drill and tap a brand new hole in that material. And so thank you very much to everybody for all of your help. I could not have done this without everybody's insight and helping me know that I was doing the right thing. And unfortunately, that is all we have time for this week. Thank you very much for watching. Till next time.
I really appreciate subscriber Daniel Lee sending me these photographs of his family in Man in a Garage swag all over Paris and London on their recent European vacation. Looks like a great time. Thanks very much, guys.